Hello, good day. I am Brian Daniel Binay, and here we're gonna solve a simple parallel to series circuit. As you can see, here's the given circuit: VS, the voltage R1, R2, R3, and R4. So R given is R. The voltage supply is 10 volts. The resistance of the resistor 1 is 10 ohms. R2 for 20 ohms. R3 for 30 ohms, R4 for 40 ohms. So the problem states that we need to find the total current, the power dissipated by the resistors, and the total resistance of the given circuit. So what we're gonna do is first is simply analyze the given circuit. So as we can see, this is a parallel to series, meaning that the order from which the positive side, the direction of the current from starting from the positive side, loop to the negative side, starts with two parallel resistors. Then next is the two series resistors. So what we're gonna do is first we prioritize what are the series resistors here. So there is the R3 and the R4. So what we need to do is simply add them. The next, the R3 and R4 will simply be identified here as R34. And then we can do three parallels along with it. So let's start. So again, in a series circuit, what we need to do in the total resistance of the circuit is just simply doing arithmetic or just adding up them. You need to remember this formula. So let's look at the given circuit again. You can see R3 and the R4. So we just need to simply add them. So R3 plus R4 plus 40 plus 30 equals to 70 ohms. Now, this resistance will be identified as R3 and 4. You need to remember that. So next, we need to visualize what will we do next. If we combine R3 and 4, what is the circuit gonna look like? So the circuit will be simply like this. This is R1, this is R2, and this is R3 and 4. Now we can see we have three parallels. So what are we gonna do? We just simply work from the right side up to the left side. Since the direction of the current is from positive to negative, simply just gonna loop around. So what we can do next is the formula for the parallel circuit. Now that we know we have R3 and 4 valuing 70 ohms, and we have R2 as 20 ohms and R1 as 10 ohms. We can do parallel by this one by one. So R3 and 4 is parallel to R2. Now if we're gonna do a parallel solving, you just need to simply remember this formula. What we need to do is, if R1 is parallel to R2, then R1 multiplied by R2 over R1 plus R2, and we will get our answer. So we're gonna do it this here. R3 and 4 is 70 times 20 over 70 plus 20. Now, if we do the calculations, this would be equal to 15.555 ohms. Now we need to remember this. So this will serve as our R2, 3, and 4 resistance. And the next, now that we have R2, 3, and 4, we're gonna visualize it again. What will the circuit look like after combining them? After combining the resistors, rather. Now, our circuit would look like this. This will be our R1, and this is our R2, 3, and 4. So, as you can see, we have again a parallel. So we're gonna repeat this formula, and let's see what is our given answer. So again, we have R1 as 10 ohms, and the R2, 3, and 4 serving as 15.55 ohms bar. Yes, this just means it's repeating. It's a repeating number. So we need to remember again the parallel. So R1 is parallel to R2, 3, and 4 is equals to 10 multiplied by 15.55 over 10 plus 15.55, and this equates to 6.088 ohms. Now this is our total resistance. Next, what do we need to find is the power and the total current. Now, to find these two, we just need to remember our formulas. VIR means voltage is equals to current, total current, multiplied by the total resistance of the circuit. Now, if we just do that, we do have a given of 10 volts. What we do not have is the total current. And we also have this 6.088. Now, if we do algebra, we can find I is equals to divide V over R. So we're gonna do that. I is equals to V 10 over R 6.088, which means our answer should be 1.643 amperes. Okay. Now, what we're gonna need next is the power dissipated. So, if we're talking about power, we just simply need to remember this formula right here. Meaning, power is equals to current times voltage. Now, we do have the current, and we also have voltage. So, we just need to simply multiply 1.643 is equals to 16.43 watts. So again, we have our total resistance, so having 6.088 ohms, and current of the given circuit is 1.643 amperes, and the power dissipated with the resistors are 16.43 watts. And that's it for today. We need to remember again that regarding solving any type of circuit, you just need to simply analyze and visualize what will we do next. So again, to recap, we studied and analyzed using the series formula, algebraic sum, R3 and R4, and this is the visualization after solving it. And next, we noticed that the circuit has now 3 parallels. So what we did was follow this parallel formula, and the visualization of the circuit became this. Next, another parallel again. So we did the parallel formula, and we calculated the total resistance. Then we need to remember this thing, the formula for the voltage and the power. And that's it. Thank you for listening, and have a nice day.